Welcome to Joe's Bench 506, and we're going to work on a Pioneer SA-6800 this morning. The issue with this is it does power on, apparently, but the relay doesn't click in. So when the relay doesn't click in, that means there's an issue with probably the DC voltage where the relay is detecting some voltage that is not supposed to be there. So we're going to do this today. We're going to check this out and we're going to power this on. Are you guys ready? Check out the dim bulb. It powered on normally, but I didn't hear the relay clicking in. Okay, so beautiful 6800, SA-6800. And again, power's on, but there's nothing is happening. There's no sound coming out of it. So the best thing to do is to open this up and see if there's anything that I can see that is wrong with this receiver. And we're just about to do that. So power it off and let's open this up. Nice veneer, looks good, eh? I like this. There we go. All right, zoom this in. There's a big transformer right here. Right here is my power supply, where the AC is turning into DC voltage. You've seen my rectifiers down there, right down here. There's my relay that's not clicking in. This would be the phono section right here. This is the tone board right here. Check out the fins. This is the heatsink. And if you're looking in here, these white resistors are the emitter resistors. This would be for the right channel, and the other ones are down here for the left channel. The left channel looks really crummy. Actually looks like it was set on fire or something, eh? Look at that. You can smell the burnt section around here. So somebody glued this to, switch is this, the loudness switch. They had an issue with that. I don't know. I don't care for that too much. But easily access to the volume. Be able to spray some stuff on there. Here's the selector switch back here. So all in all, it looks like it's going to be easy access. We will take the bottom part of it. So I'm going to flip this around and I'm going to take the bottom off. There's the bottom. And I'll show you what I have visually. Look at the white stuff on here, right? So these are my outputs right here. You see these two and these two? Those are my outputs. I'm going to be checking those. Okay. There's a bit of rust here. This is where my transformer is on the other side. Down there. So this is where it's taken a lot of heat. We will be checking some of this soldering as well. So let's see what I can find on this. Close to this. And let's check some outputs. Put this on diode mode right here with the yellow button. And I'm going to check the outputs. So this would be the right, this would be the left. Well, the right seems to be okay. This would be seems to be okay. And we'll do the left channel. I have an issue here. Yeah, I have a short on this one. I'm going to unsolder this part here, but before I do this, I want to show you guys something. And I know it's hard for you guys to see, but this guy right here is the output for the left channel. And this is the guy that's testing short. So I'm going to take this out of there. I'm going to unsolder it. And so I assume that we're having an issue with the left channel, as the right channel, this would be the right channel here, as the right channel here is testing okay. I'm having an issue with the left channel, which is this one. And you notice that I started off with the output transistors. So you guys notice that I've started off with the output transistors because the relay is not clicking in. I have an issue with the DC voltage in this receiver, and the output transistors will tell you a lot of clues. If it wouldn't have been the output transistors, then I would have moved more inward than this. But right now I'm having an issue with one of the output transistors, and this is the left one. There's a short with this one, and I believe there's a short on this one as well. Something is happening here. These two are testing okay. I have a really good junction on those ones. This is an issue. So I'm going to heat up my iron. I have a short at the collector and the emitter on this output. And the same thing with this one. And this is the one channel as well. I'm going to take this one out. So it was good to measure. So this should be measuring something here. Measuring a good junction there. Good junction. But this is open. Here, I'll show you what I mean. If you guys can see this. So out of circuit. Out of circuit, this should be, there's a good junction. Here's a good junction. But check when I check the emitter, the collector and the emitter. I have a short at collector emitter, and the same thing with this one. Okay. I have good junction there. This one is actually not a good junction. So this one probably took the hit and shorted this one as well. Now, if these are the good ones here, this is the other channel. Have good junction. There's a really good junction, and the collector and the emitter is open, which is perfect. This is a good output, and this one should be the same. Good junction. There's another good junction, and I should be open when I cross-reference the collector and the emitter, and I do. It's perfect. These two are good. These two are short. Okay, so I just realized that I have to unsolder the right channel as well. The whole heatsink is going to come out with the output transistor, so it's going to be a lot easier for us to do it. So we're going to do that right now. That should do the trick. And there it is. I'll bring you guys closer and look at this board. Now these are the outputs, okay? The NPNs, and these are the PNPs. Remember that I had an issue with only one side of this. Okay, so I believe it was, that's where my short is. And this is where my short is, at the collector and the emitter. So it's this side. Okay, the heatsink is out of there, and now that gives me full access to check more components in there, because I do have a short at the collector and the emitter. These two transistors right here on the left, this was the left that I was having them, I'm having an issue. These two drivers, you need to check those. Okay, and I'm not so sure about these emitter resistors as well. I'm going to turn this around. these driver transistors could be short. Even the emitter resistor could be short as well. So we are going to check every single components on the left channel. We can actually even compare. You notice how this is divided, eh? This is the right channel right here, and the left channel here. The very same components from left to right, so you can always check and compare. Okay, so this is always a good thing to do. But I believe that these got a lot of heat to them, so I'm not sure if these are not open. I wouldn't be surprised if they weren't open, and I wouldn't be surprised if one of these transistors may be both. I'm going to check that. And I noticed something else as well. If you check this resistor here, these two resistors, check out the color of this one, and if you compare it to the right side, so I believe this one and this one is open. These two are open. If you compare them with these ones, look at the color and the difference in the color. This one really fried, and these resistors are going to need to be changed as well. So we're going to continue on anyway, just keeping you updated on it. So what I'm going to do is I'm going to continue on. I'm not going to, it's kind of tedious to have the camera there and while I'm doing, because you really can't see anything anyway. My hands are in the way, but I'll show you the findings that I have, and we'll go from there. I believe that the one of the emitter resistor is open, two resistors are open as well, and one transistor on the driver's side, and this is all on the left channel. The left channel took the hit, so we're going to need to continue on with this. Okay, so I'm going to put you on pause for a bit. This is one of the emitter resistor. I touched it and it came to all the pieces. So this was open. This one. This one came from here. See, I had two here. This one was fried. I'm going to check this one. See the crack? These emitter resistors are done. This would be open as well. So that was a big issue. Now these two transistors are the drivers for the outputs. I wouldn't be surprised if one of them or maybe both of them are short. Okay, check out these resistors here. If you compare them with these ones, these are 47 ohms resistors. Look at the color of those compared to these. These got a lot of heat. So we're going to continue on. I am going to change these two resistors. The emitter resistors will have to be changed, so I'll have to find replacement for those. These ones are good, and these resistors are 0.22 k ohm resistor, so should be able to find those. You wouldn't be able to replace those with just any type of resistors. These are on to take a lot of heat with these, so we'll have to replace them with those. And I'm going to continue on with a couple of more components on the left channel. So this one is proving to be short at the collector emitter part of it, but maybe not though. It's going to be a good idea to take it out of circuit so then I can actually test it good. So that's what we're going to do, take it out of circuit. I'm just going to retouch these. So let's unsolder is. Good junction. That's a good junction. This is still good. So we're good with this one. And I'll also check it with this little machine. It's an NPN like I told you before, and this is a good transistor. I have my base, collector, and the emitter, and everything is working great with this transistor. So I can put this back in. I'll check the other one to make sure. I don't suspect the other one to be bad. I'm just going to stretch these legs again so it'll fit on the circuit board. But whenever in doubt, it's always nice to take it out of circuit. This resistor may be still good, but it got a lot of heat. So it would be a good idea to change it. This is supposed to be a 47. And that's what I'm measuring. I'm measuring 47. And there it is. So 47 ohms would be the resistor that I need to replace it with. Even though it measures still good, it caught too much heat, and we will replace that. There's 3 of them actually. So this one is a 47. There's a 47 ohm to replace this resistor. Shall replace it right now. And here's the other one. It's 47 ohm as well. So we'll get another 47. So I don't know if you guys can see this, but like right here is where my relay is. I'd like to take the relay out of there and you know, check it out. so I know I've insulated the outputs against the heat sinks. I know that's good to go. Okay. I've changed the emitter resistors. I put new ones in, and this is ready to go back into place. So we'll do that. And what I'm going to screw this in place. I'll keep this loose for 2 seconds. I just want to see something. Okay, that's excellent. Okay, so I'm ready to solder this. So I'll solder the outputs. I put the heat sink back on with all the new outputs that I've put on, and I'm still seeing a short, using way too much current. I plugged it in through the dim bulb, and I'm still having an issue with the left channel. So there must be a transistor somewhere on the left channel that I left out, and I thought that I would have had to check that. I've checked it, and I probably didn't. So we're gonna, there's only 2 of them. I just looked at it, and there's 2 of them that hopefully will be the case. So let's get closer, and I'll show you which one I mean. I'm showing you where that transistor came from, but first of all, I've replaced those 2 resistors there, and I am going to replace the other one as well. And this is where that transistor, both PNP and NPN, it's the NPN that I need to change. It was open at the base and the emitter, and there it is there. I'm showing it to you now. We are gonna have to change that. So I want to talk to you guys about the transistors when you check them. When you have a short at the collector and the emitter part of that transistor, it usually means that it's not an isolated issue. Usually there's other components that has been involved in the short. Whenever you have a short, let's say base to collector, base to emitter, usually that's isolated. But remember, I had to replace, there was a lot of heat on these resistors. There was 3 of them. There were 47 ohm resistor, which I changed, and obviously this was affected as well. So I'm pretty confident that once we put this in, this should be the end of the short, because I've checked every single component now. You guys can see this. There you go. I'm testing that transistor. Well, that transistor is reading as a capacitor. Completely short transistor. We're going to replace this, and I think we're going to be back in service after we do this. So we're going to continue on. We're going to replace that transistor, and we should be good to go. Okay. We've changed that, and now we're ready. We've put it all back together, and we're ready to power this on and see if the relay is actually going to click in. So I have the owner here with me. My friend Bob is with me. This is his amplifier, by the way. So we're going to power this on and see if the relay clicks in. So here we go. I'm going to power this on, because I shut this off, did I? Oh, it's on. This was off. So what I'm going to do is I'm going to start slowly. I'll go up to 50 volts with the Variac through the dim bulb, and I want to see if everything is working fine. I don't want to see any smoke coming out of this. We spend a lot of time and money trying to repair this, so you don't want to jump into the conclusion where everything is okay. So we're trying to do this slowly. So we're going to power this on. So we were at 50 volts. I don't see any activity here. I don't see any smoke coming out of this. And we're going to crank this up. Maybe Bob, you can crank it up to maybe 60 or 70. So 60, it has actually powered on the digital meter.
Awesome.
And it looks good so far. But not enough for the relay to click in. So we're gonna go up with power again. Maybe we'll go up to maybe 90 volts. Going slowly. Was that the relay?
Yeah, that was a relay.
Okay, so I'll bring you guys closer. So we're gonna shut this off, and I want to hear that relay clicking in. Okay, so here we go. The relay has clicked in. So I'm pretty happy with all this. I'll bring you guys closer to this. This is, I'm gonna turn this off, and I wanna show you what we've done. The output transistors are behind this heatsink. We've changed 4 of them just for the sake of having all of the same. The emitter resistor.
You can see them now.
Yeah, the emitter resistor right here, they were both open. They were burnt. These resistors right here I've changed. The value of the resistors were still good, but they've got burnt marks on them, so I didn't like them. And this transistor right there, so we've changed that, and we've got this thing going again. So I'm pretty excited about that. Okay, so our next step to this is I want to see what kind of voltage I'm getting, so I want to flip this over. The power is still off. So Bob, are we ready to put this on the regular outlet? I think I would like to. Everything is working fine. So we're going to shut this off. I'll shut this off, and then we can plug it in. All right, there's the power switch. Power this on. The relay has clicked in.
Clicked in even faster with more power, eh?
Yeah, more power. So, right here. Just want to see what kind of voltage I'm getting from my outputs. It's the center ones that, so we're 42. There's 42. Should have 42 here. This would be my plus. So everything is working great. Pretty exciting.
Nice.
Yeah, it looks nice. I think it's gonna work good. You have a little bit of DC voltage on here, but I do believe that as soon as you hook up your speakers to this, the voltage is gonna drop to about zero millivolts, I'm hoping anyway. So we're gonna flip this around. Shut this off.
Unplug it?
Yeah, unplug it. So my next step to this is, and this is the Phono board, and we want to check all these capacitors on there, see if they're working correctly. So what we're going to do is we're going to take this board out of there so we can check the capacitors. Okay. You took it out?
I did once. Yeah.
Oh. But why don't, you know what, I'm going to let you do this. You can do it right here, right?
I could, yeah.
So the orange ones, all the other ones are doing okay. I'm gonna go get the schematic for this while you do that.
Okay. Okay, so this one's
Just do one at a time.
Yep.
So you don't get mixed up, 'cause I don't have
Yep.
the schematic, eh?
this is a 2.2 microfarad at 50 volts. Let's get you in there. What's that? Oh, what sponge?
The sponge is it's wet now, so we might be able to do something with it.
2 microfarad at, I don't know, but look, which is the positive and which is the negative on this?
No.
I think those are non-polarized ones. That's the one I changed there. And then I figured,
Is that the one? That's the one you told me about, eh?
that's the one I told you about there, so I'm not sure. We're gonna have to figure out, I think it's non-polarized, eh? It should be like 4. It can go up to 4, I think. It said on my sheet anyway. But those orange ones are buggers, aren't they?
I mean, it's showing me 1 ohm on that, so
Yeah.
it's still acceptable.
Yeah.
So,
What's it say on this? Oh, something's not going on.
Oh, this is the power switch.
Oh.
Yeah,
It's on.
wires, you have to cut those, and above 50, you have an issue with your amp.
Yeah. Oh yeah, for sure.
So we don't want a 50 for
No.
sure. Okay, guys, the amplifier has been running for at least 15 minutes. We let her warm up, and I know I can't set the bias on this, and I can't set the DC voltage, but I've always liked to check what we're reading about the bias and the DC voltage. So I want to do it the safe way. I'm going to do it through the emitter resistor, but I'll do it on the other side of the board because it's too close in here, and I'm going blind, and I'm too worried to touch something and short anything out, and I don't want to be doing that. Now that it's working at 100%, I don't want to cause any harm to this. So I've marked them down where the emitter resistors are, and I'm just gonna measure between 2 emitter resistor, and that should give me, so I would be satisfied if it was between 2 and 50 millivolts. Anything between that, I'm good to go. So I'm gonna put this on millivolts, and then you can bring me closer so I'll show them. Are you able to see this as well? Sure you can see that, eh?
Can you turn the light on that?
No, I can't.
Can't I?
But it'll show
Yeah,
nicely.
I can see.
So I've got the multimeter on millivolts, and I'm going to go in between the 2 emitter resistors, and I'm going to measure that, and hopefully it'll be between. And there it is. I've got 12 millivolts for one channel, and I'll do the other channel right here, which is between the emitter resistor again, and I'm getting 13.7 millivolts. So I'm really pleased with that. Now that I've done that, I'll flip this over like this, and with the power still on, of course. So you want to be careful when you're doing this, okay? I'm just going to go in here and measure if I have any DC voltage. I have this on a speaker, so let's check that. I've got 33 millivolts on the left, and I've got 43 on the right, but that's without any speakers hooked up to it. I believe that if you had speakers hooked up to this, the millivolts would be lower, and we'll do that after I'm done with the bias. So what I want to do is I want to hook it up on auxiliary, and I'll give you a frequency, and we'll do sound tests on this if we can. So that's what we're going to do next. Auxiliary, right. I hope it sounds nice.
I'm gonna check this. Better check this to see if I touched anything.
No, it's good. It's when the red light is on, it's
Okay.
go with the frequency. Okay. We have this on auxiliary. Sorry, here's my auxiliary. I think it's not. That's how it's working. So we need to do, we have our own. Hey, are we on mute here or something? Oh. Do you think it's because we have this? No.
There's no speakers in? You don't have it hooked up to the speakers.
We won't
Just
put
thought-
that.
I
We
just
won't,
I felt behind that.
yeah, we won't put that on the video.
No.
Here, I'll shut this off. I want to do some measurements here. It'll do voltage. So we'll get the RMS on this one. Channel 2. There. Should be good. And we'll bring this to 10 millivolts. This is pushing what?
It's supposed to be 45.
Yeah. Okay guys, we're ready to do a sound test on this. So we're going to power this on. Listen to the relay has clicked in. And I have a frequency of 1000 hertz. It's going through the auxiliary and through the scope. And we should hear some sound right now. And there you have it. So it seems to be working great. I am going to mute this though. And we'll be watching my scope here. Bring you guys closer. There you go. Alright, so we can crank her up. Go slowly, bring it to half. And then we'll watch the scope, how it reacts. We are going to look for either both left and the right channel. These seem to be working equally at the moment. And remember, we're on an 8 ohm load. And we'll see how many wattage per channel. And where is it going to be sitting at for distortion. 20 RMS. Right now I'm getting a bit of distortion here, so we'll have to kick it back. Distortion is at 22. Kick that back there. So we're reading about 20.4. Both of them is at 20.4. So that'll give you guys, I'll put that on the screen and how much voltage that is. So we'll add that up for you guys. Okay guys, now we have it. We are pretty satisfied with the results with this after we've changed all the parts that needed to be changed. And we're going to power this off. I'm going to put this back together. And we're going to put some sound to this after we're done. Anyways, if you like the video, thumbs up and subscribe to my channel. I would really appreciate it. There. So we're done. Oh, we should, I wanted to check see how much voltage you have on this, eh? See if you have any DC voltage. I bet you it's better, right? No, yeah. It's a lot better, right? 0.03, so that's good.
It's a nice thing to add, yeah. But he said that I'd get more wattage with those. So
That's why.
So now you know how to make it better, eh?
That's crazy.
Hear what it sounds like in music.
Oh, we're gonna put it on.